Okay, so this is the general formula for the absolute value graph that we've been doing. And if we think of the normal absolute value graph, just the one that we've been doing, basing everything on, it always looked like this. And that was y equals, y equals x. So now what these values do, the m, we know, change the gradient.
Yeah.
So for example, if you had y equals minus, or y equals a half, then that would be less steep. So this is the normal, and then the half one would go like that.
So the other number was that stood before the absolute value. The greater the greater it was.
The greater the steepness, yes. So if, for example, if it had been, so that this is y equals a half x. If I put on this line, if it was something like this, we would have, this would be y equals 2x. So it's double the steepness.
So then, that was what I was about to ask. So then, if you halve the number that's in front of it, it would be half as steep.
Correct. Yes. Good.
So then, at what point would it be a straight line up and not have an angle in it?
So then there would no longer be an x.
So it would only be y.
Yeah. So then it would be like, say, y equals 0. So for example, if I had y equals 0, let's do that in purple. Sorry, x equals 0.
So it would just be a straight line on the y-axis.
It would be a straight line up like that. Oops. And if it was a very, very narrow one, so if the half kept getting smaller and smaller, eventually,
it would eventually be y equals 0.
That's right. Y equals 0. Okay, then the plus h.
Was that how far it shifted across or either way?
Good. So if you have y equals, say, x plus 2, what happens is that shifts it shifts it the opposite way from what you would think.
So then that would be the negative sign.
Shift it backwards. Good. So it would be here. And this would be a 2 here. And if it was just a normal gradient, that's a 2 as well.
Okay.
Okay, and then if it was, say, y equals x minus 2, it obviously shifts it this way. So it shifts the normal y equals x graph forwards by 2.
Okay.
Okay, and then the final thing is the plus c. Say plus 3, and that's going to shift it up by 3.
So it won't always necessarily go through the x-axis.
Not always, no.
Okay.
So this would then be shifted up by, and that would be a 3. And so if we had, say, y equals x minus 2, that shifts it down.
I'll move down to.
Yeah.
So then if it's not, so all of them are going up, so they moving into the positive of x and y. Well, actually y. So then if they all move down, would there be a minus in front of the x?
Yes, so that would be exactly. So that we could do here. I'll do it in a slightly lighter, slightly darker green here. So if we had y equals minus a half x, it's exactly the same graph, but it's pointing downwards because
so if it was a 2 or negative 2, they'd have the same they won't have the same gradient, but the angle would be the same that they had. So if it was a 2 or negative a half, or a 4 and a negative a quarter.
yes, so m tells you the steepness of the v, because these are always a v.
Okay.
If it's a negative a quarter, as you said, that's going to be along
in the middle.
So this that would be negative a quarter, and this would be negative a half.
Okay.
Okay, so that's basically what this is your general form of your absolute value equation. And you just kind of need to know what your normal y equals x does, and then how it would change based on when you added a c, an h, or an m. And if they give you one of these points, if they give you 2 points on the graph, you can then use those to calculate your m. And if you see that this is called the salient point, this here. If you see that this point here, let me do it in brown. If you see that this point, no, that's not, I'll do it in yellow. If you see that this point has been shifted either way, to the left or the right, you know that this c is going, this h is going to have a value.
Okay.
Like what we see here. It's been shifted.
Okay.
And if you see that the salient point, this yellow, is above or below the x-axis,
that would affect the c.
The c is excellent.
And would the c also be the opposite? So if it was moved up, it would be negative, or would that be stay the same? So if it moved up, it would be plus.
Up plus, yes, exactly. So the c is intuitive because it's the change in y. So it's on the opposite side of y. So if c goes up, y goes up. Whereas x, because h is on the same side as the x, if you moved it across, it would become minus.
Okay.
So as h gets bigger, x will become smaller. So it'll go in the opposite direction.
Okay.
Okay, is that all good for these absolute value graphs?
Yeah.
Okay.